All right, so to take a look at this, I'm going to use the tutor to kind of walk through the steps to help a little bit with the organization of this. So if we use a tutor, we look at this step by step. So in this case right here, I think we can do this one with addition. And the reason is because if I think about this as negative 25 over 12, so let me grab my pen. So as a little side note here, if I think of this as negative 25 over 12 and I convert that to degrees, so that'd be negative 25 pi over 12 times 180 over pi. Plug that in our calculator and we find out that that is negative 375 degrees. So with that, if I then take and pull up my, if I pull up my unit circle, what I see is that at that point, negative 375 degrees would be, we go around 360. And then we'd have to go an additional, to go to 375, we would have to go out. We got another 60 degrees. Let me hit pause real quickly on that one. So 375 degrees would essentially be like right here. Sorry about that. And so it'd be like right there, somewhere between 360 and then this next one, which would be another 30 degrees. And so that would be 390 if we added on, right? So we've gone around, we're at 360 degrees negative, right? So we've gone around negative 360 and we need to go to negative 375. So that's a total of 30 degrees. From there to there would be 30 degrees. So we cut that in half. We know that this would be an additional 15 degrees. That'd be negative 375 right there. So now our question is to be able to break this down, we have to figure out how we can do that with using an addition of two different common angles. And so what I thought about this is that if I went to right here, so let me change colors real quickly. So if I went around from 360 out to this spot right here, so that'd be 360 plus another 60, so that would be 420, right? Is that right? 360 and 60. No, that's not right. 360 plus 60. Yeah, 420. And if I take away 45 degrees from that, but then I go back 45 degrees, that would put me at 375. And that's what we needed, was at 375. And so that's this location right here. So how can I get to that 375? And that would be this idea of which two angles can I add together. So let's kind of go back over this one more time. So we start this question off. We need to go around. We've converted to, let's see if I can bring this back real quickly. Oh, look at that. That's cool. All right. So I have said to myself, okay, I have negative 25 pi over 12. I'm going to convert the degrees to help me understand what I'm looking at in terms of my circle. So then I say, okay, I start at 0. I go negative direction. I go around 360. I figure out that negative 375 is going to be someplace right in here, basically halfway between the 360 and the next pi over 6 right there. And so I say, okay, well, all right, so that's my 375. But now I need to figure out what combination of two common angles will get me there. And so I started playing around. I said, okay, well, let's see. I got to get to 375. And I know that, like, for example, if I went from 360 and I added on 45, so if I did 360 plus 45, then that would put me at 405. And then I need to try to subtract from that to get to 375. And so I said, okay, well, that's going to be 30 degrees. So that would kind of work. I could possibly do something with that also. So let's see. So 405 plus 45. So that would put me at like right here, 315. And then I would take away 30 degrees and that would put me right there. So that's another possible situation that I could do. I could use I could use a 405. But then I could sort of negative 405, and then I could add 30 to it. And the one that I did was is that I went out and said, okay, I'm going to go out to 420. So I'm going to go from 360 out 60. So I'm going to go from 420, and then I'm going to take away, let's see, from that, I'm going to take away 45 degrees. And when I do that, that takes me down to 420 minus 45. That takes me also back to 375. And so my two angles there would be a negative 420 plus 45. So either one of these would actually work for the problem that you're working. It doesn't really matter either way. But I'm going to go ahead and go with the 420 and the 45. So that means that I'm essentially using this location right here. I'm just going to draw a little line right here. Okay, and then I'm also going to use a 45. So if we count our way around, that means I have 1 pi over 3, 2 pi's over 3, 3 pi's over 3, 4 pi's over 3, 5 pi's over 3, 6 pi's over 3, 7 pi's over 3. So that means that this location right here would be negative 7 pi's over 3. Then I'd be going with that. So that's my negative 420. So let me, boom, eraser. Get rid of this for a second. Kind of clear up my spot there. Zurich. And so I'm at negative 7 pi over 3. That's my negative 420. And then I'm going to add 45 to that. Well, 45 is always the same. So that's just going to be my pi over 4. And when I add that, that'll bring me back to that negative 375. Okay, and that negative 375, when you put those two together, that's when we're going to get to that negative 12 pi, 25, negative 25 pi over 12. And so if we look at pi's over 12, which I'm not going to go through and do that. So pi's over 12 would be here, and those would be just other fractional parts. So kind of sad that the Hawks makes it that complicated. Why can't we just keep it kind of simple? But it is what it is. This is the type of question we're going to get. So we have to come up with strategies to be able to solve it. So if we added those two things together, finding common denominators, we would get our negative 25 over 12. So just as a quick side note, just so you can see that. So if I had negative 7 pi over 4 plus pi, I'm sorry, let's erase. That's not pi over 4, that's pi over 3. 7 pi over 3. Find my common denominator, which is 12. And so then that would be times 3 on the bottom. So that'd be 3 pi on top. And that'd be times 4. So that'd be negative 28 pi. When we subtract those, we get negative 25. Sorry about that. I'm getting a little bit of a hurry. It's a little bit late. Trying to get this done. I'm a little behind. Negative 25 pi over 12, which is what I was telling you is that we would get. So whole lot of little like getting around that, lots of different ways you could do this. The bottom line is that I knew that I started off and I knew I had to get the 375. And that was that thing where we knew that because this idea that we convert that, we know our angle had to be negative 375. That made it a little bit easier for us to identify and say, okay, if negative 375 would be right there. And since negative 375 is right there, how can I get to that? And so two possible answers would be here in red or in blue. I'm going to work the problem with the one in blue. Okay, so at this point, I basically know that I'm going to be able to add. I'm going to be able to add a positive and a negative, and so I'm going to choose this guy. Hit submit. Okay. So now, while that loads, so now, let's see, let's go pen, clear screen. All right, so now, basically what I'm going to do is I'm going to take what we just solved, what we just determined here with this guy, and we're going to plug that in. And that's these two numbers right here. So that's that negative 7 pi over 3 and that pi over 4. So go here. So that means I'm going to take an addition sign, use my keypad, and I'm going to start typing this in. So that would be negative 7 pi over 3. And then that would be pi over 4. All right. So, and like I said, that's going here and using these numbers down here in the blue. So that's our negative 420. That's using our negative 420 and our positive 45. If we add those together, we get to our negative 375, which is this location right here in the red where we wanted to be, which is also known as our negative 25 pi over 12 because we converted that over on the previous screen. All right, so now kind of keep moving forward. We go back to our problem. We got those plugged into our formula. We hit submit. All right, let's see what we got next. So now we're actually going to break it up. So we're going to go through, and we know that in this particular case that we have this formula. So we know that if we have the sine of u plus v, in this particular case, let's see, this is our u, and this is our v. So just a little side note right here in case we lose this. Our u is going to be our negative 7 pi over 4, and our v is going to be pi over 4. Sorry about that. It's not over 4, it's over 3. Okay, so now we got that. We're now just going to plug in. So this whole situation right here is just like plugging that into our formula because remember, we're walking our way through this particular problem. All right, so let's pull this over here so it's not in the way. And so this is literally going to be negative 7 pi over 4 over 3, excuse me. And then that's our v, and then our u is going to be pi over 4. Then it's cosine of u. So u is negative 7 pi over 3. So we got that, negative 7 pi over 3. And then sine of v, and that's going to be, let's see, pi over 4. Check that answer. Awesome. So we're cruising. We're doing pretty good. All right. So I'm just going to erase that real quickly. It's not in our way. So now we're ready to evaluate. And so this is where the unit circle is going to come back into play again. Let me get rid of that real quickly. Mouse. Okay. So now this is where our unit circle is going to come back into play. And I don't think that I've actually talked to you or to you guys about this particular situation, and that is that we have these two different possible options for, let's see, same mouse, there we go. We have two different possible options for when we're looking for angle measurements of 30, 60, 90 and 45, 45, 90. So we have two different triangles that we're going to draw and think about here. Okay, so we'll call this a 30-degree angle. We'll call this a 60-degree angle, and we'll call that 90. So on a 30, 60, 90 triangle like this, this value on that side would be the square root of 3. This would be 1, and this would be 2. So in this particular case, we're finding the measure of pi over 3. So we want to know what the sine of a pi over 3, a 60-degree angle, is going to be. And so we go from 60 degrees. Remember, sine is equal to opposite over hypotenuse. And so that means that sine, that would be the square root of 3. So opposite over hypotenuse, the square root of 3 over 2. Now, however, if we go back and we look at this, we're thinking about where we're actually looking at this angle. We're looking at this angle down here. So in this quadrant, what we have to remember is that our x values are negative. And so in this particular case, our y values are, our x values are going to be positive, our y values are going to be negative. And so that basically means that this value is going to be a negative term coming out of there. And so when we do that, we go back. So this is actually going to be a negative 3 over 2. Sorry about that. I can't erase that. So that's going to be negative 3 over 2 for that. And so we'll go ahead and put that in right here. So keypad, pull that over here, fraction bar. So this is going to be a negative square root of 3 over 2. Sorry about that. And then we have to find the cosine of pi over 4. So because this is a positive pi over 4, a little bit different situation. So positive pi over 4, we come back to the unit circle. And so we're looking at a pi over 4. We're going in this direction. And so that would be a pi over 4 is always going to be a square root of 2 over 2. So this would be fraction square root of 2 over 2. Oops, I'm sorry, I had that backwards, my bad. We look at the triangle first, okay? So we're not looking at that. So if we also have a triangle that we call a 45, 45, 90. Let's just change colors. So we also have a triangle that's a 45, 45, 90. And so in this particular triangle, this would be a 45, this would be a 90, and that would be a 45. We know that the lengths of these sides are 1, 1, and square root of 2. So if I did the cosine of any one of those, that would be adjacent over hypotenuse. So that means that the cosine is equal to adjacent over hypotenuse. And so in that particular case, our cosine of pi over 4 would be 1 over the square root of 2. So it'd be 1 over the square root of 2. Okay, then over here, now we're doing the cosine of the 60-degree angle. So we go back and we're doing the cosine of pi over 3, or negative 7 pi over 3. And so we look at this guy, and the cosine would be adjacent, so that'd be 1 over 2. All right, so that would be 1 over 2. And so then we would put that guy right there. So in here we would have 1 over 2. And then we would have, for the next one, we would have the sine of pi over 4. And so pi over 4 would be opposite. So that'd be 1 over the square root of 2. So that'd be 1 over the square root of 2. So we come back inside of here, and we type in 1 over the square root of 2. All right, let's take a look at that and see how we did. All right, awesome. So a whole lot of stuff on there. You've got this video. You can go back, rewind, kind of think about how we got there. Let's see what the next step brings us. So I'm going to go ahead and clear the screen so we can kind of see our work. Oops, sorry about that, wrong button. Okay, so now here I am, and now it's time to do the algebra behind this problem. So I'm going to grab the pen and go ahead and start working this out. So on this side, we're going to multiply these two guys right here together. So on top, we get negative square root of 3. On the bottom, we get 2 square roots of 2. On this one, we multiply that. We get 1 times 1. That gives us 1 over 2 square roots of 2. So, there's like different ways you can kind of address this. It might actually be easier just to go ahead and take care of this like individually first and say to ourselves, okay, well, we can't have a radical in the denominator, so we need to multiply by the same radical. And so what that does for us is that ends up giving us, on top, negative square root of 6, because we have the same square root, so we can multiply them together. On the bottom, that gives us 2 square root of, and then we can take the 2 and the 2 and put those together, and that gives us a square root of 4. And we'll simplify that in a second. Over here on this one, we would do the same thing. So because it's exactly the same denominator. And so we would multiply the top and the bottom by we're multiplying the bottom by the square root of 2 to get rid of the square root. But whatever we do to the bottom, we have to do to the top. And so then what this ends up giving us is we get plus, on top, we get square root of 2, and we get 2 square roots of 4. Now, the beauty of what happens here is this. We have the square root of 4, which is equal to 2. So then that comes out as 2. So we get 2 times 2. So our denominator turns into 4. And on top, we have negative square root of 6. On this one, same thing. We have the square root of 4 is 2, right? So we know the square root of 4 is equal to 2. So we have 2 times that 2 gives us 4 on the bottom, and then a square root of 2 on top. So when we simplify this, our final answer would be negative square roots of 6 plus the square roots of 2 over 4. And nothing simplifies because of the fact that everything's inside a radical. So we can't take evens out because these aren't actually like a 6. It's a square root of 6. And so there's no common factor between those two. Oh, excuse me. So now test that answer, excuse me. So we got our fraction bar. We've got negative square root of 6, arrow out, plus the square root of 2 over 4. Oops, let's get rid of that 3 that got hit on there by accident. All right, we test that answer, and boom, we got it. Okay, so go ahead. I'm going to kind of let this run for a second. You can go ahead and I'm going to clear the screen. You can always rewind or go back. That way we can see everything. All right, so now we've completed this question. So those are all of the steps that will get us through this process. There's a lot to it, so that's why I decided to use the actual tutor part, because that way you can see all the steps along the way. I think that's the best way. It kind of helped me keep it organized. Please let me know if you have any questions. That's definitely a challenging question. That's not going to be an easy thing to overcome, but you can do it. Remember to break things down into your degrees to be able to find what your radians are, and then to work through with those radians to be able to test things out. Take copious notes so that way you have that as a reference.